Hi guys, welcome back to Data Every Day. Today we're looking at a data set of beer consumption in São Paulo. And basically it's taken from, I believe it says, groups of students from ages 18 to 28. And this is giving each record for a different day of the year. And we're going to try to predict the beer consumption for a given day of the year based on a series of features. So let's get into the notebook. We're going to use various forms of linear regression to make our predictions. And actually, let me import the models that we're going to use. We're going to use a bunch of different linear regression models here, not XGBoost. That was from before. It did not perform very well. Linear regression, ridge regression, lasso regression, elastic net regression, which is just a combination of ridge and lasso, stochastic gradient descent regressor, and a Huber regressor, which is robust to outliers. So let's go ahead and import all these. I note we're using NumPy and Pandas just to work with the data. Regular expressions, standard scalar, and train test split function from sklearn for pre-processing. And then we're going to analyze the results with the R2 score. Actually, we don't need R2 score because it's built into these regressors from sklearn. Okay. So let's load in the data using pandas.read CSV. And we can get the CSV file right over here. Copy it in, paste it in, take a look. So you'll notice we have NANs on the bottom. Let's take a look at the info, the data.info. And you can see we only have 365 non-nulls in each column, which is interesting because we have 941 rows. So there's 600 in each that are not that are missing. So let's start pre-processing. And I just want to take another look at this. I'm going data.isNA. Gives us true or false if there's a missing value in a given location, and we can sum across the rows to get the total number of missing values in each column. If we don't sum but instead take the mean across the rows, we'll get the percentage missing in each column. So there's 61% in each column missing, and when you see that every row has exactly the same amount missing, it's usually because there's blank entries in the data. So we're going to create this function called preprocess inputs. It's going to take in a data frame, which in this case will be data, and it's going to return x and y, where y is the column we're trying to predict, which is this beer consumption in liters. Right, I'll just get that column, make a copy of it, and store it in y. And x is going to be everything except that column. So we're dropping it from axis 1 and making a copy as well. So it's going to take in df. Let's actually make a copy of our data frame, so we're modifying a fresh version. And then we're going to split it and return. So now we have an x, which is what we... Oh, actually, let's store it, right? X comma y equals preprocess inputs. Passing in data now. And now we can look, we have x and we have y. Y is what we're trying to predict. X is what we're using to predict it. And I'm just going to go ahead and drop all these rows. So I want to see what happens if I drop, so let's say drop missing rows. We can use df equals df.dropNA, which will drop any missing rows or columns depending on the axis we specify. And we're going to do axis 0 for rows. And then when we drop rows, I'm not sure if they're spread out or if they're all in the end, so I'm going to reset the index afterwards. Drop equals true will keep the old indices from becoming a new column. Now we'll return this, take another look. You can see we now have 365 rows, and this makes sense because it says there's a period of 1 year in this data set. So I'm guessing there is just a bunch of extra rows in the end, and what the actual data is 0 through 365. And these should have no missing values since we dropped them. So if we go, if we take a look at the isNA.sum, we get 0 missing values in each column. Alright, next in pre-processing, let's take a look at the data types of x, so x.dtypes. You can see we have all of these object columns. For date, the date column, that makes sense because it's a string and we're going to have to change that. But for these ones, everything except the weekend column, these are all object columns. When relayed, they should be numeric, they should be floats. Right? And the reason for that is because we have commas instead of periods on the entries. So what we're going to do is replace all the commas with periods using regular expressions. Now we don't necessarily have to use regular expressions here, but I feel like it's pretty easy to do that, so let's go ahead. First, let me just mark this down, split df into x and y. But now here, after we drop the rows, we're going to just deal with these columns, right? Just these four. And we're going to iterate through. So for column in this list, so just turn this into a list of strings with column names. Alright, so for each column, df subcolumn is going to equal df subcolumn dot apply. So we're applying here a lambda function that takes a given x, which will be a given one of these values, and we're going to replace x with regular expressions dot substitute, and we're going to target any commas we find and replace them with periods, and we're going to apply that to x. And then when we're done, we're going to turn it into a float. So numpy.float of that. So what this is doing is taking x, which is a given one of these strings, replacing commas with periods, and then turning it into a float at the end. So we should have everything in numerical form when this is done. I'm going to run that, and you can see we now have periods here, and if we check the data types, everything is in a float form except the date columns, which we're going to deal with right now. So right here, replace commas with periods in numeric columns. And now here, let's create date features. So what I mean by that is we have this date column, right? df subdata. If we note this is actually a string or object column, right? Now pandas has a nice function called pandas.toDateTime, which will actually convert the column into a datetime format. So it automatically goes in and detects the form, and then it will assign this value to year, this value to month, and this value to day. So we're going to just set the column equal to datetime form, and then we're going to extract each piece of information and store it in its own column. So we're going to have a year column. I know this is in English, everything else is not, but doesn't matter. I speak English. So we're going to grab the date column and apply a lambda function to it. And so for example, we're going to get this year column. All we have to do is x.year. Then we can do it again and again. One for month, one for day. And this will be month and this will be day as well. Alright, so after that we can just drop the original date column from axis 1. And that should give us 3 new columns. So let's run that, take a look. We now have year, month, and day, and the original date is gone. Everything is in float form. And I think we're ready to scale the data. So y, also then ands are gone. This is good. We're trying to predict the actual values of y. So let's scale x. Okay, so after we split it into y and x, we don't want to scale y, so we're only going to scale x, but with a standard scaler. So I imported this at the top. Standard scaler is going to give each column in x a mean of 0 and a variance of 1. This will allow the model to perform better because all the columns will take on a very similar range of values. So scalar is going to be a standard scaler, and create a new object, and then x equals scalar.fit transform x. And so this will fit the scalar to x, which means it'll go into each column, it'll find the min and max, and then scale it accordingly so that each column has a mean of 0 and unit variance. This actually returns a NumPy array, so I'm going to turn it back into a data frame so we can keep looking at it nicely, keeping the column names the same as they were before. Alright, let's check it out now. Now everything takes on a very similar range of values. Most of the values in each column lie between -1 and 1. And you'll notice that the year column has all zeros. So if you scale data and you notice that it's all zeros in the column afterwards, that usually indicates there's only one unique value in that column, because it just got shifted to 0 and there's no variance at all. So let's take a look. We're going to take just that column, which is year, and look at the unique values in it. And sure enough, there's only 0, so this column is not useful to us because there's only one value. So we're going to go ahead and just remove the year altogether, and we're only going to generate month and day features from the original date column. Now we're going to run through. Now we are ready to start training our models. Let us begin training. And first I'm going to split the set into a train and test set. So we're going to have xtrain, xtest, ytrain, ytest. We're using the train test split function from sklearn. We're going to pass in x, y, specify a train size of 70%, and a random state of 1, 2, 3. I mean, this doesn't matter, just so that we can reproduce the results, because this function actually shuffles the data as well as splitting it. So to ensure that the shuffle is always the same, we're going to include a random state there. Okay, and now we'll set up our models. So we're going to have a bunch of different models. I'm going to make this a dictionary that's going to map a model name to a model actual instance of the model. So we're going to have regular linear regression. So new instance, and we'll call it linear regression, right? Okay, then we're going to have ridge regression, or L2 regression, using L2 regularization. Then lasso regression, which is L1 regularization. And we're going to have elastic net regression, which is basically a trade-off between ridge and lasso regression in the same model. Elastic net. Then we're going to have SGD regression, stochastic gradient descent regression, which is just regression using the SGD algorithm. SGD regression. Actually, I think it's regressor. That's how we imported it. And then we have Huber regression, which is it's a regression that's built to be very robust to outliers in data. Huber regressor, I believe it's called. Okay, and then let me just line these up so that we can display them side by side nicely. We can display the results, and we can compare more easily. All right, so now we have our dictionary of model names to models. And what I'm going to do is for every model in models.values, so it's going to target only the actual objects, model.fit on the train set, xtrain, ytrain. So this will fit our models, and Huber, I misspelled. All right, there we go, they're all fit. And now we can view the results and compare. So for name, comma, model, in models.items, so this items function will return the key values as pairs, as tuples, which we can then iterate through 2 at a time like this. And we're going to print out the name of the model, and then r² score, colon, space, and then I'm going to display it to 4 decimal places. We're going to format that string with model.score on the test set, xtest, ytest. And we can see the results. It looks like linear regression and ridge performed well, along Huber trailing right behind them, and then the best one of all was the stochastic gradient descent regression with a r² score of 0.69, which is very good. It's interesting. I tried using boosting methods, ensemble regression on this, and it did not perform as well. These individual models seem to be doing the job. Alright, so that will sum up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.